Have you ever wondered why so many college students perform poorly on tests and tasks? Having helped learning assistance professionals and peer staff conduct thousands of test recitations, it's clear that students bring some level of content knowledge to their tests and tasks. For example, when taking a test, certain words may register with them. However, when it comes to the moment of truth, where they must produce an answer, students find themselves stumped or unable to produce a sufficient response. When this happens, it's a clear sign that the thinking skills students use while studying do not match the inherent cognitive skills that are being assessed. Solving this dilemma requires us to understand how academic material is organized, and to dissect the content from students' thinking skills and from the academic products their thinking produces. We will use the ThinkWell, LearnWell diagram to guide us through this process of academic product development. Academic material is organized around outcomes. Outcomes can only be produced by mixing the proper cognitive skills with the correct content. While content is narrowly focused, outcomes cover broad spans of content. Therefore, the material covered in a class and in text over the span of weeks may be necessary for producing a single course outcome. The critical point you must know is that the thinking skills students enact on content determines the knowledge products they produce. Just to be clear, knowledge products are the mental fruits of students' academic labors. They are the mental items students draw upon to answer test questions, solve problems, write papers, and so forth. All courses have statements that define the essence of the course. These are labeled as learning outcomes, objectives, or course goals, and they are usually included near the beginning of a course syllabus. For example, learning outcomes typically include an action verb such as explain, analyze, describe, or evaluate, and are paired with course content. These action verbs provide critical clues about the modes of thinking that are needed to produce the outcomes. Students who lack the ability to properly decipher their outcomes and activate the appropriate thinking skills will likely waste time doing unbeneficial academic work. However, those who can decode outcomes and deploy the proper thinking skills will save time and be greatly rewarded for their academic labor. Decoding course outcomes depends on students' ability to differentiate their thinking skills. So a great starting place with any student is to teach them this essential threshold skill. Differentiating one's thinking skills means that we know how each respective thinking skill qualitatively changes how we interact with and what we ultimately learn from content. For example, let's say you're taking a course on metacognitive thinking and are presented the following 3 types of knowledge: declarative knowledge, procedural knowledge, conditional knowledge. If this information is new to you, then thinking skills associated with remembering will automatically be activated. Ultimately, regardless of how long you study, you will produce knowledge products consistent with the remember level of thinking, so you might be able to accurately recall the definitions. If you're a diligent student, then you would have studied the material a few times before the test. But if you had not deliberately changed your thinking skills, then your academic work will have resulted in remembering level outcomes. Okay, now let's say you show up for a test with these knowledge products firmly fixed in your mind and face the following question. A student taking a chemistry course keeps getting the algebra portion of the work wrong. Explain the roles that declarative, procedural, and conditional knowledge play in this scenario. At first, you would probably feel good because the terms declarative, procedural, and conditional will ring familiar. But then you would be confounded because to answer this question, you would have had to use your understanding, application, and analyzing modes of thinking. According to research, you likely will have provided a superficial answer that would have earned you a mediocre grade. Your problem wasn't that you didn't study enough, nor was it that you didn't know the content. Your dilemma was nuanced. You didn't learn the content well enough. And that's the state of most students. They study, but because they use the wrong thinking skill, they don't learn the material they must learn well enough. So they fall short, and they get mad. Really mad. The ThinkWell, LearnWell diagram user's guide is the best tool to give students command and control of their thinking. You can order it from the LearnWell Project store. Here's one of the tactics you'll find yourself using all of the time. The first step is to use the second column of the Think Well, Learn Well diagram, the thinking skills column, to match the level of thinking expressed in the learning outcome. Each row of the diagram represents a specific type of interaction and a precise set of cognitive skills. The key meta question we train students to constantly ask themselves is, what type of cognitive activity is the outcome signaling? There are numerous variations and synonyms of the 6 skills represented by each row of the diagram. We must help students match the thinking skills expressed in their outcomes to each of these rows. For example, let's look at content from a history course written as 2 different outcomes. First, notice that the content doesn't change even though the outcomes or knowledge products change. Each outcome is based upon the same content. Historical arguments. However, they require students to use very different thinking skills on the content. The change in the modes of thinking students will use cause the content to be represented differently in their minds, which will produce very different knowledge products. Using the Think Well, Learn Well diagram, we see that the words construct original in the first outcome signal us that the professor wants students to use the creating thinking skill, located at the bottom row, middle column of the diagram. Now, let's look at the second iteration of the learning outcome. Use primary source research material to explain the origins of historical arguments. The word explain signals us that the professor wants students to use their understanding mode of thinking on the content. So while the content remains the same, the mode of thinking about the content changes. This cognitive modification produces the type of interaction with the content and results in a qualitatively different knowledge product, one that matches the outcomes the teacher seeks. So this means that 2 students who attend class together and study together can end up with very different scores. The student who decoded the course outcomes and activated the correct thinking skills produced the proper knowledge products, while her friend wound up wasting time using the wrong thinking skills. This is the impact of metacognition that has led researchers to note that students with advanced metacognitive skills will outperform their peers. Now it's your turn to decode course outcomes and experience the rich benefits of metacognition. Remember these tips as you move forward. Number 1, underperformance is a signal that students are using improper thinking skills. When students perform below their expectation, they have likely misjudged the cognitive element of their task. Number 2, students must think well to learn well and perform well. This is one of those fundamental sequences of academic work. And number 3, use the Think Well, Learn Well diagram to align students' thinking to their course outcomes. Join the more than 3,000 colleges and universities who are using this tool to help students take command and control of their thinking, learning, and performance.